So let me go through an isotope. So these are all an isotope of hydrogen. Now, if you look at the periodic table, hydrogen is 1, 1. Okay, the bottom number is the number of protons, the top number is the number of neutrons plus protons. So if you got 1 proton, that means my number of neutrons over here has to be 0 neutrons, right? Because 0 plus 1 is 1 at the top. Here is hydrogen 2. So this is hydrogen 2. And this is going to be basically 1 neutron and 1 proton added together. And down here is 1 proton. Then you got hydrogen 3, which is going to be 2 neutrons this time, 1 proton and 1 proton. Now, look at this. The proton number always stays the same. So that the atomic number, this proton number, always stays the same. But the number of neutrons, however, can change. So it could go from 2 neutrons, 1 neutron, or in this case, even 0 neutrons. So an isotope has the same number of protons. The element has the same number of protons, just has a different number of neutrons. Now, this doesn't change the properties too much. It does make it a bit unstable, makes it a bit unreactive, and it does change the atomic mass. It does make it heavier. The more neutrons you have in the nucleus, the more heavier it's going to be, because a proton and a neutron has the same mass. So if you keep the proton mass the same and you're just increasing the neutron mass, you're making it heavier and heavier and heavier. So some of them change with physical properties, such as the density, how much, because you've got more mass. Remember, density is mass divided by volume. So because you've got more atomic mass, you've got the same volume, your density also goes up. You've got a changing in the melting point, boiling point, and so forth. Now, because they got too many neutrons, they become a bit unstable. And because they become a bit unstable, they have to stabilize. So they give off some radiation. So this is actually useful for medical reasons. There's just a wide range of things we could use this radiation for. And there are some isotopes are rarer than other isotopes. The more stable it is, the more common it is. The less stable it is, the more uncommon it is, because it's going to deteriorate and become the more stable form of that element. So, for example, these two want to stabilize and become hydrogen 1. So this hydrogen 1 is the most common isotope of hydrogen. This is called deuterium. So we call it deuterium. It's just 2 protons. And this is known as tritium. You can find this actually in seawater. It's not so common. They're used in nuclear weapons. This is the most common isotope of carbon. So it's carbon 12. And then you've got carbon 14, which is less uncommon. It's actually used in, you find out the ratio of carbon 14 decays to carbon 12. So it becomes carbon 12. So slowly the carbon 14 actually becomes nitrogen. And then what they do is they work out the ratio, because living things get this carbon 14. And then when it's not living, it slowly deteriorates. I'll make a separate video about carbon dating. But what you can do is look at the ratio of carbon 12 and carbon 14. And then you can do carbon dating. So we could see how old something is. So usually we do this to kind of find things up to as old as 600,000 years old. Then we use a different method after 600,000 years old. But carbon dating could tell us if a fossil is 5,000 years old, 10,000 or 20,000 years old.